the Pythagorean Theorem and distance formula. First off, when we talk about the Pythagorean Theorem, it's always with a right triangle. And then there's a couple pieces of this triangle that we need to know. First off, these are legs. I'm just going to call them leg A and leg B. And that is your hypotenuse. The side opposite the right angle is always the hypotenuse. And the Pythagorean Theorem is just leg A squared plus leg B squared equals the hypotenuse squared. More commonly it's seen as A squared plus B squared equals C squared. So remember, our Pythagorean theorem was A squared plus B squared equals C squared. So when we determine the third side of a right triangle, we're already given our A and B. So we've got 3 squared plus 4 squared equals our C squared. 3 squared is 9, 4 squared is 16. So our C has to be 5. Now with this next one, same idea, except notice we don't have an A anymore. Works the same way. A squared plus 36 equals 64. Subtract, we get 28. So our A is just root 28. And so what we can do is, let's see, this is 7 times 4, which is 2 times 2. So this will actually become 2 root 7. And now this last one, same idea, we're given our A, so 10 squared plus B squared equals 15 squared. So B is 5 root 5. Now, on to the distance formula. Using our Pythagorean theorem, we can figure out what the distance between R and Q is using our Pythagorean theorem. RQ squared, notice that's our hypotenuse, is going to be this PQ squared plus RP squared. But notice between P and Q over here, your y's are the same. So really the distance from here to here is just the difference in your x's. So it's wherever x2 minus x1. It's that distance. We still have squared. Now with RP, notice here your y's are the same, or your y's are what's different. Your x's are the same. So your distance is just however high this one is minus how high up this one is. Squared. This is still equal to our hypotenuse squared. But if we wanted just that distance, not that distance squared, we could take the square root of both sides, and we're left with this. And this is our distance formula, but we will get a recap on the next page. So here's our distance formula, and this is going to be between 2 points. So, find the distance between these 2 points. Leave the answers as radicals if necessary. So what we're going to do is we have the distance, we've got our x2 minus our x1 squared plus our y2 minus our y1 squared. So we'll have 5 squared plus 13 squared. 5 squared is 25, 13 squared is 169. So we get the square root of 194. We cannot simplify that anymore, so we're done. On this next one, it's the same thing. Our second x minus our first x, quantity squared, plus our second y minus our first y, quantity squared. Negative 5 minus 1 is negative 6. 6 plus 7 is 13. Negative 6 squared is 36. 13 squared is 169. We get square root of 205. And that also cannot be simplified. And so we are done.